Hello, myself Amar Pute from SP College Pune. Today we are discussing about the some basic things which it depends upon the numbers theory. At that time I am directly going to the set of prime numbers because set of prime numbers is one of the basic part or one of the most important part in number theory course. So if you observe the definition of prime number, an integer p is strictly greater than 1 is called a prime number or a prime in case there is no divisor d of p satisfying d is lies between 1 to p. That means in the prime number have no any divisor, that means which is strictly greater than 1 and less equal strictly less than p. So for example, if you take 5, then 5 have no any other divisor except 1 and 5, and if those number which is not a prime, it is called composite number. So for example, if you observe here one thing, that set of prime number is also infinite set, as well as set of composite number is also infinite set. After that, here I am discuss one of the most important theorem. It is called fundamental theorem of arithmetic. Every integer n greater than 1 can be expressed as a product of primes. So this theorem is basically called fundamental theorem of arithmetic. That means if we take any positive integer which is strictly greater than 1, we can express this integer as product of primes. So here two cases arise. That means either if we select this n as either prime or composite. So in first case, suppose this n is prime. So in the first case we are done. Now we are going to the second case. So in second case, suppose n is not a prime, then we can expand n as two composite number, n1 and n2, by using definition of composite number. So now here again two cases arises. That means either n1 is prime or n1 is composite. So in the first case, suppose n1 is prime, then we are done. But if n1 is not a prime, then we can expand n1 as n3 into n4, where n3 and n4 is proper divisor of n1 as well as n1. So therefore again, but we already select n as finite number, so therefore we can't expand n as infinite product of primes, infinite product of composite number. So that means in the final, that means this process is terminate, and we get finally we get the finite prime factorization of this n. So that means we are done. Thank you.